Taylor-Maclaurin polynomials in series. Number 8, find the first four non-zero terms in the Taylor series centered at 2 for the function f of x equals ln of 2x plus 1. I do want you to notice on this one that there is a common Taylor polynomial for ln. Unfortunately, that Taylor polynomial is centered at 1, so we cannot use that common formula because it doesn't work because we are centered at 2. So if I'm looking for the first four non-zero terms, I'm assuming that we're going to have, remember, we're going to have this constant, and then we've got something to the x, and then something x squared, and then something x cubed. So if we have 4 terms, we're pretty much usually going to be out degree 3, usually unless we're dealing with cosine and sine. So I need to find, and my little side trip is going to be finding the derivative. So f is equal to the natural log of 2x plus 1. My first derivative is going to be du over u, which is going to be 2 over 2x plus 1, and if I rewrote this so I can get more derivatives, it's going to be 2 times the quantity 2x plus 1 to the negative 1. Okay, my second derivative is going to be negative 2x plus 1 to the negative 2 times the chocolate, which is going to be that. So this is going to be negative 4 times the quantity 2x plus 1 to the negative 2. And then my third derivative is going to be 2x plus 1 to the negative 3 times the derivative of the inside, which is 2. So this will be 16 2x plus 1 to the negative 3. So that I can work with these, I'm going to rewrite this as negative 4 over 2x plus 1 squared, and this one will be 16 over 2x plus 1 cubed. All right, so just keep that in mind as we're doing these. All right, so the first term, we want a Taylor series. We're just going to Taylor series, or P equals, however you want to put it. My Taylor series is going to be, the first one is going to be f of 2 plus f prime of 2 x, and that's just it, and then plus the next one is going to be f double prime of 2 x squared. Actually, it's not going to be x, it's going to be x minus 2 because we changed our center, x minus 2 squared, and then the next one's going to be f triple prime of 2 x minus 2 cubed. This one is over 3 factorial. This one actually should be over 2 factorial. So that's the formula that I'm going to use. Now I just need to plug things in and actually get an answer. So we're going to have f of 2. And if any of these were to turn out to be 0, we need 4 non-zero terms, so we'd have to go out another term if necessary. Okay, so when I plug 2 into this first one, 2 times 2 is 4, plus 1 is 5. So I'm going to get the natural log of 5, okay, plus f prime of 2. If I were to plug 2 into this next derivative, I'm going to get 2/5 x minus 2, and then plus the second derivative. If I look at that second derivative, if I plug 2 in here, I'm going to end up getting 5 squared on the bottom, so it's going to be negative 4/25 x minus 2 squared over 2 factorial. And then the last one is going to be the triple prime. So if I had to plug 2 in here, that's going to give me 5 cubed on the bottom. It's going to be 16/25 x minus 2 cubed over 3 factorial. And now just simplifying this one more step, I'm going to get natural log of 5 plus 2/5 x minus 2 minus 2 factorial is 2. So if I take 4/25 times 1/2, I am going to get 2/25 x minus 2 squared, and then plus 3 factorial is equal to 6. If I take 6/25 times 1/6, I am going to end up getting 8/375 x minus 2 cubed. So that would be my Taylor series, the first 4 non-zero terms. All right, number 9, find the third degree Taylor polynomial centered at 0 for the function f of x is equal to tangent x. And on this one, once again, we do not have a common Taylor polynomial for this one. We do for sine and cosine, but unfortunately not for tangent. So what we are going to do on this one is just do some work here. Okay, so f is going to equal to tangent x, and I know I need a third degree, so I have to find the third derivative. The first derivative is going to be secant squared x. The second derivative, I am going to have to use the chain rule. This would be 2 secant x, and then the derivative of secant x is secant x tangent x. So rewriting that, that would be 2 secant x squared times tangent x. And then it looks like to get our third derivative, we get to use the product rule. So f and g, f prime will be 4 secant x times secant x tangent x, which equals 4 secant squared x tangent x. G prime is going to equal, the derivative of tangent is secant squared. And so then there we go. So my third derivative is going to be f prime times g. So that's going to be 4 secant squared x tangent squared x, because we're going to multiply both of the tangents together, plus f g prime. So f already has secant squared, so another secant squared will be secant to the 4th, so 2 secant to the 4th x. So that's looking like a lot of fun at this point in time, but here we go. Alrighty, so my third degree Taylor polynomial is going to be f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x cubed over 3 factorial. Alright, so now let's just plug in what we know. F of 0, the tangent of 0 is simply 0, and then plus f prime of 0, secant, remember, is 1 over the cosine. The cosine of 0 is 1. So this will be 1 divided by 1 is 1, 1 squared is 1, so this will be 1x, so just x. And then plus the second derivative here, where are we? Here's my second derivative. And we already know in my second derivative that my tangent of 0 is going to equal 0, so this whole expression is just going to equal 0, so that's all we're going to have on that one. And then plus this one, we're going to have the third derivative. This, again, since there's a tangent in it, the whole thing is going to be 0 on that part, but secant to the 4th is 1 over cosine, which was equal to 1. 1 to the 4th is 1, times 2 is 2, so this is going to be 2x cubed over 3 factorial. So if I simplify this out, my polynomial is going to be x plus 3 factorial is 6, so I'm going to get 1/3 x cubed. And it didn't say how many terms I had to have, it just said I had to have a third degree, and I do. So that should be it. Okay. Number 10, write the Maclaurin series for f of x equals cosine the square root of x. Be sure to include the general term in your answer. Okay, unfortunately for this one, if you would like to do it the long way, go for it, but getting the general term sometimes is a little bit more difficult. On this one, since we have a common Taylor polynomial, if you have the cosine x polynomial memorized, you are all set on this one. So I'm going to have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus ... and then the general term is negative 1 to the n x to the 2n all over 2n factorial. So all we need to do on this one is wherever there's an x, we are going to insert the square root of x. Okay, so if we do that, we're going to have 1 over, instead of x, we're going to put the square root of x squared over 2 factorial plus the square root of x to the 4th over 4 factorial minus the square root of x to the 6th over 6 factorial plus ... plus negative 1 to the n square root of x to the 2n, and then it will be over 2n factorial. All right, so now if we just simplify this, we're going to get 1 minus the square root of x, if you squared, is just going to be x, so it will be x over 2, and then plus, because 2 factorial is 2, this would be like 2 times 2, so when the square and the square root cancel each other out, and then I'd get x squared still, so I'm going to have x squared over 4 factorial is 4 times 3 times 2 times 1, which is going to be 24, and then minus, we've got the square root of 6, that's going to be like 2 times 3, so on this one, the square root of x squared just cancels out, so we're going to have x cubed over 6 factorial, 6 factorial, let's see here, 4 factorial is 24. 24 times 5 is, 24 times 5 is 120, and then 120 times 6 is 720, so that will be that. And then my general term, it said we had to include, this is going to be negative 1 to the n. And then the square root of x squared, the square and the square root cancel each other out, so we'll just get x to the n over 2n factorial. And there we go on that one.